miles, I'm going to show you how to measure the path lengths of optical cells used for measuring CD spectra. I'm using the interference method, which works for cells with path lengths of 100 microns or less, and it's necessary because the actual path length deviates considerably from the value given by the manufacturers, and this is especially so with the very short path length cells of say 5 to 10 microns. The types of cells I'm talking about are these demountable round cells that you can purchase with path lengths from 5 to 100 microns, or this type of cell, or rectangular cells like these. You'll need access to a UV spectrophotometer, normally used for measuring absorption spectra. I'm using a Carry 3 instrument, but the software should be roughly the same for all instruments. You need to set it up to measure a baseline corrected transmission spectrum from 800 nanometers to 400 nanometers. Select baseline correction and transmission mode. Run a baseline with nothing in the sample chamber. Then all you need to do is assemble the empty cell and a cell holder. Load it into the sample chamber of the instrument. This is the fringe pattern. It's caused by interference due to reflections from the internal surfaces of the cell. Choose a fringe at the high wavelength end and note its wavelength. Call this wavelength 1. Now choose a fringe at the low wavelength end. Call this wavelength 2. Now put these values into this formula where n is the number of fringes from W1 to W2, where W1 is fringe 0 and W2 is fringe n. In this case, the path length turns out to be 14.5 microns, although the manufacturer's value was 10 microns. Now turn the cell by 45 degrees and remeasure the transmission spectrum. This time I get 14.6 microns. A third run gave 14.4 microns, so we can say that this cell is 14.5 plus or minus 0.1 microns. The manufacturers claimed that this cell had a path length of 10 microns, but using this value would result in a large error in the magnitude of the spectrum and consequently in any analysis performed on the spectrum. In summary, you can get large errors in the magnitude of your CD spectra if you don't know the exact path length of your optical cells. This especially applies to optical cells with path lengths of 100 microns or less, and so you should always use the interference fringe method to measure the path lengths.